Hello students. So we were discussing in the chapter on arrays in C, and we had written a few programs like printing the elements of an array, then finding out the sum of the elements of an array. Let us have a look at some more programs involving arrays, which you will also be doing in your practical. So say this is a program to find the largest element of an array. So if you are given an array which contains the elements say 5, 1, 3 and 7, then your output should be 7. 7 is the largest element of that array. Okay. So how to write a program for finding out the largest element of an array. So we start with an integer I, that is the variable, index variable. The name of the array is say A, and the size of the array is denoted by n, and then L is a variable which will give us the largest element of the array. Okay, so the printf statement will enter the size of the array. We'll say that we'll ask the user to enter the size of the array, then scanf will take the input, and then the elements of the array will be entered. So this for loop in the last lecture you have seen. So it will print what is the array that we have entered. Next we assign the value L equal to a naught to the variable L. Okay, so we can assign any other value here. Okay, so first let us begin with a naught, and then we will keep on comparing the values of other array elements with this L. Okay, so we need to find out the largest element of the array. So initially we take the value of L to be a0. So we start the comparison with a1, right? So for I equal to 1, I less than n, I plus plus. If ai is greater than this value L, then L will take the value of ai. Okay. So if a1 is greater than a0, then a0 is not the largest element. So let the largest element L be supposed to be a1. Okay. It may happen that a1 is not the largest. We may get some more largest element in the next iteration. Okay, so whenever we get a larger element than the current value of L, okay, we change the value of L to that larger value. Okay, so that is why this command, if ai is greater than L, then assign ai to L. Okay, so this is a comment that I have written. It's not a part of the program, right? So it's just for your understanding. So whenever ai is greater than L, L will take the value of ai. So ultimately it will compare all the elements. Okay, so the largest element ultimately will be assigned to the value L. Okay, so and after that we can print the largest element. Largest element is L. Okay, so let us see how this program runs. So it's /program 27 array. So enter the size of the array. Say we enter the array of size 6. Say the elements are 7, 9, 1, 0, 56, okay, 4, right? So largest element of the array is 56. Okay, so what it does is first it takes the value of L as 7. Okay, then it compares between a1 and 7, right? So 9 is greater than 7, so L will take the value of 9. Next it will compare 1 and 9. 1 and the current value of L. Current value of L is 9 now. So 1 is not greater than 9. So there will be no change. L will remain as 9. Then 0 and 9 will be compared. There is no change. 56 and 9 will be compared. Since 56 is greater than 9, so L will be assigned the value 56. And then 4 and 56 will be compared. Right. So 4 is not greater than 56. So the value of L will not change. So value of L will remain as 56. That way we can extract the largest element of the array. Okay. Similarly, we can write the same program, similar program for finding out the smallest element of an array. Okay. So exactly the same thing. So we start with the variable L equal to a0 and compare it with a1, a2 up to an minus 1. If ai is less than L, then we change the value, because we need a smaller element. So once we get a smaller element, the value the variable L takes that smaller value. Okay, so that's how we can extract the largest smallest element. Okay. So this is the program. Enter the size of the array, so it's 5, then 6, 3, 2, say 45, 0. So the largest or smallest element of the array is 0. Okay, so we could have written the same program using some other value of L, it's not a problem. So we start with a random value, say L equal to 30, right? And but in that case we have to compare every elements, right? So see, the same program can be written in this way. So you have to compile it again. GCC program 28 array dot c dash o prog 28 array. Okay. So if you enter this dot slash prog 28 array. You can say 56. Oh, sorry, the maximum size has to be something less. Okay, so by mistake I have entered 56 here, so I need to enter 56 values, or you can just close the program. Ultimately it will show you some error because the array was defined to be of maximum size 15. Okay, so that's the error that I get. Okay, so let us enter something within the range. Maximum size is 20, so let's say 6. Enter the elements 1, 2, 56, 3, 4, 0. Okay, so smallest element of this array is 0. So that's how we can compute. So let us see another one, 29. Program to sort the elements of an array in ascending order. Okay, so here for understanding this, let us see one animation that I have created. Sorting ascending, yeah. So it will give us the concept of sorting in ascending order. Okay, so suppose we want to sort two elements, sort these elements of an array. Suppose the array has 5 elements, and initially they are not sorted in ascending order. Okay, so our job is to sort them. So 1 should be in the first place, then it should be followed with 2, 5, 12 and 15. Okay, so what we do is we start with the first place and compare the first place with every other place. Okay, whenever, so let me just run this. So suppose I compare 12 and 2 first. So since we are sorting in the ascending order, so since 12 is greater than 2, so the ascending order should be 2 and then followed by 12. So we need to interchange the value, the places of 12 and 2. Okay, so that is what is happening. Okay, so whenever 12 and 2 are found here, yeah. So whenever at the beginning 12 and 2 will be compared, right? 12 and 2 will be compared, and since 12 is greater than 2, the places will be swapped or interchanged. Okay, so this is what is happening in the first step. Okay, then again the first place will be compared with the third place. Okay, so 2 and 5 will be compared. So between 2 and 5, 5 is greater, so it is already in the ascending order, so there will be no change. Okay, next 2 will be, the first place will be compared with the fourth place. Okay, so out of 2 and 15, 15 is larger, so there will be no change, right? Then the first place will be again compared with the last place, the fifth place. Now the fifth place element is 1 and 1 is less than 2, so the order should be 1 and then 2. That means we need to interchange the first and fifth places, and that is what is happening. This is interchanging. Okay, next what happens, so first place has been compared with all other places, and since we have compared the first place with every other place, we are now sure that whatever element is there in the first place is the smallest element. That is what we need in the ascending order, right? Next we come to the second place. So second place, there is no point in comparing second place with the first place again, because first place has already been compared. So second place will be compared with the third place. So 12 and out of 12 and 5, 12 is greater. So the order should be 5 and then 12. So that means we need to interchange, right? So we are interchanging, right? Then the second place again will be compared with the third place. Okay. So this 5 will be compared with 15. So 15 is already greater than 5, so they are in the correct order, so there is no change. Then the second place will be compared with the fifth place, and they are not in the proper order, so we have to change their places. Okay, so this is what we do, we change it, right? Next, so second place has been compared with every other place, so we are sure that the second smallest element is in the second place. Okay. Next, let us go to the third place. So third is compared with the fourth one. So here 12 and 15, they are in the same proper order, so we don't need to change. Then the third is compared with the fifth one. So 12 and 5, they are not in the correct order, so we need to interchange, swap the places. Okay, so this is what is happening. So the third place has been compared with every other place. So we are sure that the third smallest element is the third largest element is in the third place. Okay. Then we compare the fourth and fifth elements, right? So out of fourth and fifth elements, 15 is greater, so they are not in the proper order, so we need to change them. Okay, so this is what is happening, right? So 12 and 15, they interchange. Okay, so now we have the array in ascending order. Okay, this is the ascending order: 1, 2, 5, 15, 12, 15. So just let us have a look again at the animation and see what is happening. We begin with this 12 and 2, they are compared, they are changed. 2 and 5, no change. 2 and 15, no change. 2 and 1, there is a change. Then 12 and 5, there is a change. 5 and 15, no change. 5 and 2, there is a change, right? Then 12 and 15, no change. 12 and 5, there is a change. Okay, then 15 and 12, there is a change. Okay, so that is how the elements are sorted. Okay, so this is the sorted representation here. Okay, this is the sorted representation. Okay, so let us see how we can write the program for sorting. Okay, so we start with an array, and we need two variables here, I and j, and here we need a variable t, which is called a temporary variable. Okay, so you will see where it is used. So initially we just these are just for entering and printing the array. So the process of sorting begins here at this step. Okay, so these steps are the sorting steps. Okay, so we begin with I equal to 0. So we need two for loops here. So as you have seen in the animation, the first place is compared with every other place. Okay, then the second place is compared with every other place starting from the next one. Okay, so we need two for loops here. So for I equal to 0, I less than n minus 1, I plus plus. For j equal to I plus 1, because we need to compare the next place. There is no point in comparing a0 and a0. Okay, so a0 has to be compared with a1, a1, a2, a3, like that. Okay, so that is why it is j goes from I plus 1 to n. Okay, j plus plus. So whenever ai is greater than aj, since we are arranging in the ascending order, so if we get an element which is greater, okay, if we compare ai and aj, the greater will be moved to the second place and the smaller will be moved to the left place. Okay, the greater will go to the right and the smaller will go to the left. Okay, so that means if ai and out of ai and nj, if ai is greater, okay, then we interchange the values of ai and nj. Okay, right? So if ai greater than aj, then interchange, or this process is called swapping, swap the values of ai and aj. So how to swap? We use a temporary variable here. So the value of AI is kept in a temporary variable t, and then AI takes the value of AJ, and then AJ will take the value of t. Okay, so we cannot write here AI equal to AJ. So if we do that, what will happen? The AI will take the value of AJ, and in the next step, if we write AJ equal to AI, they both will take the same value. Okay, so we need a temporary variable here. Okay, so the concept is quite simple. Suppose we want to swap these two places. Okay, say, right. Suppose this is one place. This is another place. I want to swap the values of the variables here. Say this is x, and or say I write this one as 12 and this one as say 25. Okay, or say 2. So 12 is greater than 2, so we need it in the other order. So what we can do is we need to change these two values. Okay, so we introduce a temporary variable here, or say empty box. Then what we do, we put this 2 here. Okay, or say we put this 12 here, right? So once we put this 12 here, this place becomes empty, right? And then we bring this 2. So we bring this 2 at this position. We bring this 2 to this position. Okay, so 2 comes here, and so this place becomes empty. Okay, and then we take this 12 to this position. Okay, so 12 comes here now. 12 comes here, and this place becomes empty. Okay, so this is what is happening, swapping. Okay, so this extra box that we use, that is the temporary variable t. Okay, so t takes the value of 12 first, then the place of 12 is filled with the value of 2. Okay, and then the value stored in t, that is 12, is stored back in the AI. Okay, in the variable AI. Okay, AI or AJ. Yeah. T takes the value of AI, then AI takes the value of AJ, and AJ takes the value of t. So value of t is actually the original value of AI. Okay, so this is what is swapping. So this code is for swapping. So the array in ascending order is this, right? So let us see how it works, this program. So it was ./program29 array. Enter the size of the array. Say we start with a small array. Enter the elements of array. So let us not give it in the ascending order. So let's say 5, 1, 12, say 6, 48. Okay, like that. So the unsorted array was 5, 1, 12, 6, 48. The array in ascending order is 1, 5, 6, 12, 48. Okay, so this is the ascending order, right? So the concept that is used was explained in the video. Okay. So similarly, you can write a program for this one, program number 30, to sort the elements of an array in descending order. Okay. So what we do is just the same thing, but we change when AI is less than AJ, because we want it in descending order. So if we get a smaller element, so if we get a smaller element at the beginning, so that smaller element has to go to the right side. Okay, and bigger element has to come to the left side. Okay, so if out of A0 and A1, if A0 is less than A1, then A1 and A0 has to be interchanged. Okay, so that is the code, right? ./program30 array .c. Sorry, .c is not required. Program 30. Okay, so 6. Say let us take the elements 1, 9, 0, 56, 3, 2. Okay. Say to 12, right? 6. So the array in ascending descending order is 56, 12, 9, 6, 3, 1. Okay. So these are very important. These questions are asked in the practical examinations as well. Okay. So this was about one-dimensional array. The next topic is the two-dimensional arrays. So let us just have a look at this. So two-dimensional arrays, the analysis of data often requires the storage of information in tabular format. Okay? For example, the details of employees in an organization may require the following tabular information. Say employee, name of the employee, A, B, employee ID, salary, tax, etc. Okay. So such information can be stored in two-dimensional arrays, which are also called matrices. Okay, so in mathematics we have already learned what are matrices. So a two-dimensional array is declared as this. The type is written first, and then the array name, and then the row size. So there are two dimensions. One is the row, another is the column. Okay, so for example, int a 10 5. It will declare a to be a two-dimensional array of dimension 10 by 5, 10 rows and 5 columns. Okay, so how many values it can store? It can store 10 into 5, that is 50 elements can be stored. Okay, so how these elements are stored? Let's say this way. So the first element is a00, first row first column, first row second column. Okay, first row second column, first row third column, first row fourth column, like that, first row fifth column. Okay, this is the second row. A10 is the second row, 11 is the second row second column. Okay, that way the elements are stored. Okay, so two-dimensional arrays can also be initialized by writing the list of elements within braces. However, while initializing, it is necessary to mention the size of the second dimension. Okay, the first dimension is optional, and the following are valid initializations. Int a23, so it's a two-dimensional array with 2 rows 3 columns, so 589 104. The same thing can also be written without the inner second brackets. Okay, so the compiler will automatically understand that 589 they belong to the first row, then 104 belong to the second row. Okay, so we can leave this first place blank, but the second place has to be mentioned. Okay, so because if we do not mention, what happens is that if we leave both the places blank, there is a confusion regarding the size of the array. Okay, because 3 into 2 is 6, 1 into 6 is also 6, right? So if we just enter 6 elements here, there will be a confusion whether it is a 1 row 6 column array, or 6 row 1 column array, or 2 row 3 column array, or 3 row 2 column array. That is why it is required that the second dimension at least must be mentioned. Okay, so let us see some program to write this two-dimensional arrays, matrices. Say matrix. What was that program? Program 31 maybe. Yeah. Program to enter a matrix and display it. Okay. So how to enter a two-dimensional array? So we need these two variables. These are the index variable aij, right? M is the number of rows, n is the number of columns. Okay, and this is the array int a 10 10. So enter the number of rows, scanf %d %n. Enter the number of columns. Okay, enter the elements of a. Now here you see we need two for loops, because the first for loop will be for the rows and the second for loop will be for the columns. Okay, so for I equal to 0, I less than m, I plus plus. For j equal to 0, j less than n, j plus plus. So note that we did not require any bracket here, because after the for statement there is a single for statement. So automatically it is inside this loop. Okay, so if we need several statements, in that case we need to put brackets. So for j equal to 0, j less than n, scanf %d %aij. Okay, that is how it is mentioned. So the printf, the matrix is this. Okay, so let us see how it works. So for printing the matrix also we again need two for loops here, and then printf %d aij. Okay, so let us see how it runs. Program gcc program 31 matrix 31 matrix. Okay. 31 matrix, right? So dot slash prog 31 matrix. Okay. So enter the number of rows. Suppose I enter 2 rows 3 columns. Okay, enter the elements 4 5 6 1 2 3. Yes, the matrix is, see, 4 5 6 1 2 3, but this doesn't look like a matrix. So what was the problem in our program? Let us see what was the problem. Problem was somewhere here. For I equal to 0, I less than n, m, I plus plus. For j equal to 0, j less than n, j plus plus. We have written printf %d, but we have not given any space. So we have to give one space here, \t. Okay. Now let us see. Yeah. Number of rows, 2 rows, 3 columns, say 4 5 6 1 2 3. Okay. But see, still there is some problem. We have got spaces now. Between 4 and between the elements we have got spaces, but what is happening, we had wanted a matrix of 2 rows and 3 columns, but here you see we get a matrix only of one row, okay, and 6 columns. Okay, so that is a problem with the display commands that we have written. Okay, because after the first row is written, we need a space, means we need to go to the next line. Okay, and that is what we have not written. So please be careful. We have to write this command for going to the next line after the second for loop ends. Okay, outside the second for loop, inside the first for loop. Okay, so we need a new line command here, \n. Okay, so this command is required. So see, so printf \n. So after the for loop, j loop, that is the column loop is over, the control will go to the next line. So next row will be printed in the next line. Okay, so now let us see what happens. 2 row 3 columns, so 4 5 6 1 2 3. Okay, now the matrix is okay. 2 row 3 columns. Okay, so let's say 3 row 2 columns, 4 5 6 0 1. Okay, so it's 3 row 2 column. Okay, so we have written a correct program. Right, let us see another one. Program to enter a matrix and display it. Okay, now so let us write it in some more detail. So enter the columns, enter the rows, enter the elements row wise. So we have written something extra here. So we want to, while entering, we want to make sure that the user also understands what he is entering. Right, so we have added some extra things here. Printf row %d, which row you are entering, printf which elements you are entering, a0, a1, a2. Okay, these things we have introduced extra. Okay, so you may try writing this program also and see what happens. Right, control q. So /program32 matrix, and enter the number of rows, say 3 row 2 columns. See, so row 1, row %d I had written. So the ith row is actually, the first one is I equal to 0, but we had written it as I plus 1. So the display is row 1. Okay, because in general we start counting with 1. So in C, indexing starts with 0. So for display purpose, we can just trick the computer to display it as to display the first row first column element as A11 instead of A00. Okay, in the internally it will be stored as A00 only. This is just the display that we have given. Okay, so just say 2 4 5 6. So first row is over. So when the value of I becomes 1, we go to the second row. So it's row 2. So we are entering the elements of row 2. Say we are entering the elements of row 3 now. So the matrix is this. Okay, so this is another way of formatted input. Okay, so this is what we have done, right? Okay, so let us try another program. So this is 33. Program to find the transpose of a matrix. Okay, so this is also a very important program for your exam purpose also. So we want a matrix and its transpose. So initially we enter the elements like this in the usual way, and then printf the matrix A is, we display the matrix also, so that we can understand that the transpose that we have calculated is proper or not. Okay, so the ijth element of the transpose is jith element of the original matrix. Okay, so this is the only concept that is required. So we have an m by n matrix. So while displaying we are displaying with m rows and n columns. While displaying the transpose, we have to display it with n rows and m columns. Okay, that is what that is the interchange that is taking place. Okay, and we have to print AJI instead of AIJ. Okay, so we are printing the transpose. So let us see how this works. Enter the number of rows, say 3 row 4 columns. Enter the elements. So say these are the elements randomly I am entering. Right. So this is the matrix 2 5 6 1 first row. See for the transpose, the first row is 2 5 6 1. Okay. The first second row for the matrix is 2402. The second column for the transpose is 2402. Okay, so 3120 is the third row of the matrix. Third column of the transpose will be 3120. Okay, so our program is okay, right? So let us see another program to find out the sum of two matrices. Okay, program to find the sum of two matrices. So we have two matrices here, I, J, M, N. So initially you enter the matrix A. So to find out the sum of matrices, the order of the matrices should be same. Okay, so the number of rows and columns should match. Okay, so we are entering A, entering B. Then we are displaying. This is for displaying the matrix A, right? And this part is for them displaying the matrix B. And then we display the matrix A plus B. Okay, so the command is all similar, just you need to understand that we are printing the sum. So here we will use Aij plus Bij. Okay, sum of two matrices. The ijth element of the sum is the sum of the ijth elements of the member or the matrices concerned. Okay, sum of the corresponding elements, ijth elements of the two matrices. Okay. So this is the program. You can write this program. Okay, so it's not that difficult. Just you have to be careful about the brackets and indentation. Okay. So let us see how this runs. 34. Enter the number of rows. Say 2 rows, 3 columns. So enter the elements. Say this. So matrix A is 4 5 6 1 2 3. Matrix B is 4 1 2 0 2 3. So what is the sum? You verify. 4 plus 4 8, 1 plus 1 1, 5 plus 1 6, 2 plus 2 4, 6 plus 2 is 8, 3 plus 3 is 6. Okay, so we've got the sum, right? So let us see what else. The product. So what is the product of two matrices? So you need some idea about matrix theory, which you have done in the first semester of your mathematics honors course, and even in higher secondary you have done what is the expression for the product of the two matrices. Okay, so ijth element of the product is summation of ikth element of A multiplied with kjth element of B. Okay, and that is the sum. Right, so we need something like this. So printf. So if you can't recall, so ijth element of the product is Cij. Ijth element of the product is the summation of I goes from k goes from 1 to say n. Okay, k goes from 1 to n of A ik multiplied with B kj. Okay, so that is how the product of matrices is calculated. Okay, so we will be just using this concept. Okay. The ijth element of the product is summation k goes from 1 to n aik multiplied with bkj. Okay, and two matrices are conformable for multiplication only when the order of the first matrix is say m by n, and the order of the second matrix has to be n say by say P. Okay, only then they are conformable for multiplication. Okay, so these are the concepts that we have already learned. So this will be used. So two matrices A and B are conformable for multiplication only when the first matrix is of the type M by N and the second matrix is of the type N by P. That is, the number of columns of the first matrix is same as the number of rows of the second matrix. Okay, so this is what we will be using. So let us see. So we enter number of rows of A, number of columns of A. Then we don't ask for the number of rows of B because number of rows of B will be N itself. Okay, so we just ask for the number of columns of B. Okay, and then these are the commands for entering the elements of A, entering the elements of B. Then we display the matrix A, display the matrix B. So these things we have already written, and from this portion onwards, we will just calculate the product A into B. Okay, so what is that? The product matrix AB is for I equal to 0, I less than M. So the product will be of order M by P. Okay, so the first two will be for the loop for row will be from I equal to 0 to M. Loop for column will be J equal to 0 to P. Okay, and then we need to find out a summation. So we initialize the element ijth element to 0. Okay, and then this summation will run from here for k equal to 0, k less than n. Summation goes from 1 to n. Okay, so here it is in C, it is from 0 to n minus 1. Okay, same thing. So Cij is Cij plus Aik multiplied with Bkj. Okay, so it's like sum equal to sum plus I that we have already seen. Okay, because summations in programming are calculated this way. Okay, so the new value of Cij is old value of Cij plus Aik into Bkj. Okay, and then we'll print Cij, right? So let us see how this runs. Program 35 matrix. Okay, enter the rows of A, say 2. So let us initially try with a identity matrix. Any matrix multiplied with the identity matrix is the matrix itself. So the second matrix that I am entering is the identity matrix, just to verify whether the product is correct or not. Okay. So 4, 5, 6, the first matrix, 1, 2, 3. The second matrix is the identity matrix. The product should be same, 4, 5, 6, 1, 2, 3. Okay, so it's working. So let us see another one, 2, 3 and 3, 2. Oh, sorry, we entered something wrong. Okay, so let us see another one, 2 row 2 column, or say 2 row 3 column, and the other one is 3 row 2 column. Okay, so let's say 1, 2, 3, 4, 0, 6. Okay, another one is 2, 1, 0, 1, 3, 0. Okay, so this is the matrix A, 1, 2, 3, 4, 0, 6. This is the matrix B, 2, 0, 2, 1, 0, 1 and 3, 0. Okay, so you just manually you can compute the product. First row multiplied with the first column here. So 1 into 2 is 2, plus 2 into 0 is 0, plus 3 into 3, 9, 9 plus 2 is 11. Okay, second one is 1 plus 2 is 3, plus 0, so it's 3. The second row first column element is 4 into 2 plus 0 into 0 plus 6 into 3. So it's 18 plus 4, that is 4 into 2 plus 6 into 3, 18 plus 8, it is 26. Okay, so that way the product is verified. Okay, so let us see another program. Yeah, so this program has been coming a few number of times in the practical examinations. So it's a program to construct a simple calculator for computing sum, difference and product of two matrices using a switch statement. So we have already seen how to write a program for constructing a simple calculator for adding, subtracting, multiplying, dividing two numbers. So the concept is similar here, even though the program is a bit lengthy because you need so many for loops here. Okay, so since we are writing the program for sum, difference as well as the product, so we need to define all the rows and columns of both the matrices. Okay, So let us take the rows and columns. Enter the number of rows of A is M, number of columns of A is N, number of rows of B we enter as P, number of columns of B we enter as Q. Okay. So from this portion onwards, it's just entering the elements of A and B and then displaying the matrix A and B. Okay, so these portions are same, and from here we begin with printf add, subtract, divide or multiply. Okay, so enter your choice, scanf %d ampersand choice. So if the choice is 1, so we have entered M, P, N and Q randomly, or the user will enter randomly, or say by mistake he may enter some value which is not conformable. So we need to check here. If M is not equal to P, for addition the orders should match. So M should be equal to P and N should be equal to Q. So if any of them are not equal, then we will print a message that not conformable for addition. Okay. So else if they are equal, then we can find out the sum, just like we have already seen in the earlier program, Aij plus Bij. Okay. Then case 2 is for subtraction. If the same condition for subtraction also, the orders of the matrices should match. So if the orders do not match, then we write not conformable for subtraction. So the matrix A minus B is just Aij minus Bij. Okay, the change comes here, right? Then similarly case 3, for case 3 we need to check whether the number of columns of A is same as number of rows of B or not. So here the number of columns of A is not, if it is not same, then it's not conformable for multiplication. So we'll display that. Else if it is same, then we'll just write the program for the product. Okay, so here we have written exactly similar. If you know the programs for the sum, difference and product, it's very simple to write. Okay, though writing it is quite lengthy, it's a lengthy task, so you need to practice this. Okay, so let us see how it runs. Okay, program 36, matrix, enter the number of rows of A. So I enter 2 and 3, and I enter something else here, 4 and say 1. Okay, so it will take the elements as input initially. Okay, so the matrix A is this, matrix B is this. Suppose I want to add this two. So what it will display? It will display that it's not conformable for addition. There is an order mismatch. Okay, because for addition the order has to be same. Okay, so let us try another one. So 2 3 2 3, because now we are entering it in the same order, so now it should not be a problem. Okay, so the matrix A is 1 2 3 4 5 6, 1 2 3 4 5 9. Suppose I want to subtract. Okay, so if you see the difference is this. Okay, suppose I enter I want to multiply now, so I enter 2 3 and here I enter again 2 3. Okay, now what is the problem that I will get? Okay, suppose I want to multiply. So matrix A is 1 2 3 4 5 3, matrix B is 2 row 3 column again. So I should get the message that it's not conformable for multiplication. Okay, so see, we have got that it is not conformable for multiplication. So what I have to do, I have to enter it carefully. So it's 3 2, so that it's conformable for multiplication. So your calculator should be able to perform these checks. Okay, so the product of the matrix is this, right? So this was the program so far. So for as far as the chapter on matrices is concerned, we have done everything here, addition, multiplication. So there is a program for writing the finding out the determinant of a 3x3 matrix. So I'd like to give you this as a task. You try to write it, write a program to compute the determinant of a 3x3 matrix. Okay, so let's try it and write the program. Okay, so in the next lecture we'll start with another unit. This was the 5th unit, so we'll start with the 4th unit, that is the function. That is the last unit for your course, and yeah, so let us see. Thank you.